Welcome to another deep dive. Today we're turning our curiosity to something we all experience pretty much constantly, light.
Yeah.
I've been looking into this Wikipedia article on quantum optics.
Okay.
And honestly, it's made me question everything I thought I knew about how light works.
Yeah.
You know, we all know light allows us to see, it helps plants grow, but
Right.
have you ever stopped to think about what light is?
It's fascinating, isn't it? For centuries, as a species, we were
Yeah.
content with the idea that light traveled in waves.
Mm-hmm.
But as with many things in science, the deeper you dig, the stranger it gets.
It really does.
And more wondrous.
Yeah, and that's where this idea of photons comes into play, right?
Exactly.
These like almost mythical little packets of energy.
Yeah.
So are they particles or are they waves?
That's the million-dollar question, and the answer is both.
Okay.
And it's what makes quantum optics so mind-boggling.
Yeah.
Think of it this way. Imagine a flowing river. You can see the current, the waves, but at its core, the river is made up of countless individual water droplets.
Right.
Photons are kind of like that, both a continuous stream of energy and distinct little bundles of it.
Wow, okay.
Yeah.
So it's not like anything we experience in our everyday lives,
Right.
where something's either a solid object or a wave rippling through water. It can be both at the same time.
At the same time.
How did scientists even begin to wrap their heads around that?
It was a series of groundbreaking discoveries that completely revolutionized our understanding of physics.
Okay.
It all started in the late 19th century with Max Planck. He was studying why hot objects glow different colors, what we call black body radiation.
Right.
And he found that the energy emitted wasn't continuous,
Okay.
but came in these discrete packets, these quanta, and that the energy of each packet was directly related to its frequency.
So that's where we get the whole quantum thing from.
Yes.
This idea that energy, it isn't this smooth flowing thing, but more like a staircase with very specific steps.
Exactly.
Okay.
And then just a few years later, Einstein enters the picture.
Okay.
He takes Planck's idea of quantized energy and uses it to explain the photoelectric effect.
Okay.
You know how solar panels convert sunlight into electricity?
Right.
That's the photoelectric effect in action.
Wait, hold on.
Yeah.
So those panels on rooftops generating clean energy are using the same principle
The same principle.
that governs these tiny packets of light.
It's wild, right?
How does that even work?
It's pretty amazing.
Yeah.
Einstein proposed that light isn't just a wave, but also acts as a stream of these energy packets, these photons.
Okay.
When a photon hits a material, like the silicon in a solar panel, it can transfer its energy to an electron, knocking it loose and creating an electrical current.
Mm-hmm.
This was huge because it provided direct evidence that light could behave like a particle.
Okay, that's mind-blowing. So we've got Planck setting the stage,
Yeah.
Einstein demonstrating that light acts like a particle, but we're not done yet, are we?
Not even close.
Okay.
A few years later, Niels Bohr joins the party.
All right.
He was trying to figure out why atoms, when energized, emit light at very specific wavelengths, creating those unique spectral lines we see when we break light apart with a prism.
Okay, I vaguely remember that from high school physics.
You know those lines?
Yeah.
Bohr had a light bulb moment, no pun intended.
Okay.
He realized that these specific wavelengths corresponded to the energy differences between different energy levels within the atom. It was like the electrons were confined to specific orbits around the nucleus, like planets orbiting a star,
Right.
each orbit with a fixed energy level.
So these electrons are like picky eaters at a restaurant, only willing to exist at specific energy levels on the menu.
That's a great analogy.
Right.
And the really cool part is when an electron jumps between these energy levels, it either absorbs or emits a photon of light
Okay.
with energy that exactly matches that energy difference. That's what gives rise to those specific wavelengths of light we see.
Okay.
This is where the connection between light and the quantum world really starts to solidify.
It's incredible to think that these discoveries from the early 20th century weren't just about understanding light.
Yeah.
They were about unraveling the very fabric of reality at the smallest scales.
Absolutely.
It's almost like we stumbled into a secret quantum realm hidden beneath the surface of our everyday world.
Absolutely. And the deeper we dive into this quantum realm, the more bizarre and wondrous it becomes.
Right.
It's like those early pioneers of quantum mechanics handed us a treasure map, and we're still uncovering its hidden wonders.
Okay, I'm ready for more treasure.
Right.
We've talked about photons, energy levels, and the dual nature of light.
Right.
What are some of the real-world implications of all this? How is this knowledge shaping our world today?
Well, that's where things get really exciting. Quantum optics isn't just about theoretical physics.
Okay.
It has led to some truly groundbreaking technologies.
Yeah.
Take lasers, for example. The very word laser stands for light amplification by stimulated emission of radiation,
Okay.
a process that relies entirely on the quantum properties of light,
Mm-hmm.
specifically the ability to coax atoms into releasing photons in a synchronized way.
So instead of a jumble of photons going every which way, a laser produces this perfectly coordinated beam of light,
Yeah,
all the photons marching in step.
exactly. And that coherent beam of light,
Yeah.
with all its photons having the same wavelength and traveling in the same direction,
Right.
is what makes lasers so incredibly versatile.
Yeah.
Think about it, from barcode scanners at the grocery store, to fiber optic cables that power the internet, to laser surgery that can correct vision with incredible precision. Lasers have revolutionized countless aspects of our lives.
It's amazing how something that operates at the level of individual photons can have such a huge impact on our macroscopic world.
It really is.
Yeah.
And it doesn't stop there. Remember we talked about quantum entanglement earlier?
Yes.
That spooky action at a distance?
Right.
Where two particles become linked, even across vast distances.
That still boggles my mind. It
Yeah.
feels like something out of science fiction.
It does, doesn't it?
Yeah.
But it's a very real phenomenon.
Okay.
And it has the potential to revolutionize fields like communication and computing.
Okay.
Imagine a world where we could transmit information instantly and completely securely using entangled particles.
Right.
It would be like having a direct line of communication that bypasses the limitations of speed and security that plague our current technologies.
That would be incredible.
Yeah.
But before we get too far ahead of ourselves,
Sure.
I am curious about some of the more technical terms I came across in my research.
Okay.
Like, what exactly is a coherent state?
Right.
You mentioned lasers earlier.
Right,
Is that what you meant?
Good catch. Yes, a laser beam is a perfect example of a coherent state.
Okay.
It's basically a state where all the photons in a beam of light are oscillating in sync, like a perfectly choreographed dance. This synchronized state is what gives lasers their unique properties.
Okay, that makes sense.
Yeah.
But then there's this other term, squeezed coherent state.
Right.
What does it mean to squeeze a state of light?
That's where it gets even weirder. Imagine you have a balloon filled with air.
Okay.
Now imagine squeezing the balloon on one side.
Okay.
You're not changing the amount of air inside,
Right.
but you're redistributing it.
So you're saying we can kind of squeeze the uncertainty in a beam of light, making some of its properties more precise at the expense of others.
Exactly. It's like focusing the uncertainty.
Okay.
In a squeezed state, we can reduce the uncertainty in one aspect of the light, like its amplitude or phase, which makes it incredibly useful for precise measurements.
Okay, that makes sense.
Yeah.
Like focusing the power of the light in a specific way.
Right.
What about spontaneous parametric down conversion?
Yeah.
It sounds like something out of Star Trek.
It's a mouthful, but
Yeah.
the concept is actually pretty cool. It's a way to generate those entangled photons we were talking about earlier.
Wait, so this is how we actually create those linked pairs of photons that seem to defy the laws of physics?
Yeah.
How does that even work?
It involves shining a laser beam through a special crystal.
Okay.
Now, under the right conditions, a single photon from that laser beam can split into two photons, each with lower energy.
Mm-hmm.
But get this, they remain entangled.
Okay.
It's like splitting a beam of light with a prism.
Right.
But instead of two identical beams, you get these two interconnected photons that share a spooky link.
This is incredible. It's like we're not just observing the quantum world, but actually learning to manipulate it photon by photon.
Yeah, it's really remarkable.
Where does this all lead?
Well,
What's next for quantum optics? What other mind-blowing possibilities are on the horizon?
we're really just at the dawn of the quantum era, and quantum optics is leading the charge. One area where we expect to see huge advancements is in quantum computing
Okay.
instead of bits, which can be either 0 or 1. Quantum computers use qubits, which can exist in a superposition, a kind of probabilistic blend of both states simultaneously.
Okay.
This allows them to perform calculations in parallel, tackling problems that would take classical computers billions of years.
It sounds like something straight out of science fiction.
It does, doesn't it?
A computer that can explore countless possibilities at the same time. What kind of problems could we solve with that kind of power?
The possibilities are truly astounding.
Yeah.
We could revolutionize medicine by simulating complex molecules to design new drugs and therapies. We could crack the codes that protect our most sensitive data, leading to unbreakable encryption. We could even unravel the mysteries of the universe by simulating the conditions of the Big Bang.
Wow.
It's a whole new frontier of computation.
Okay, wow. I'm starting to see why quantum optics is considered such a groundbreaking field. We've talked about revolutionizing computing, but what about communication?
Right.
You hinted at the potential of entanglement earlier.
Right. Quantum communication leverages the bizarre properties of entangled photons to create ultra-secure communication channels.
Okay.
Imagine a system where any attempt to intercept or eavesdrop on a message would instantly alter the state of the entangled photons, alerting both the sender and the receiver to the breach. It would be the ultimate form of unhackable communication.
So instead of relying on complex algorithms that can be cracked,
Right.
we could have a system where the laws of physics themselves guarantee security.
Exactly.
That's incredible.
It's really amazing.
And it's not just about security.
Yeah.
Quantum communication could also enable faster-than-light communication,
Right.
at least in a way.
In a way.
Because entangled particles are linked even across vast distances. Changing the state of one instantly affects the state of the other, regardless of how far apart they are.
Yeah, you're getting it. It's really quite amazing.
I'm completely captivated. I started this deep dive, curious about light, and now I'm hearing about unhackable communication and faster-than-light possibilities. It's mind-blowing.
And you know what? What's even more exciting is that we've only scratched the surface of what's possible with quantum optics.
Really?
Scientists are exploring new ways to manipulate and control light at the single photon level,
Wow.
leading to even more exotic applications like quantum teleportation, not of people like in Star Trek, but of information.
It sounds like we're on the verge of a technological revolution powered by light.
I think so.
It makes you appreciate the elegance and strangeness of the quantum world, doesn't it?
It really does, and it reminds us that the universe is full of surprises. And the more we explore the quantum realm, the more awe-inspiring and full of potential it becomes.
This deep dive has been an incredible journey. We've gone from the basic nature of light to mind-blowing technologies that sound like they're straight out of science fiction.
It's amazing, isn't it?
It makes you wonder what other secrets of the universe are waiting to be unlocked, perhaps hidden within the very light that surrounds us. Until next time, keep those minds curious and never stop exploring.